So when we're proving all the different identities, we said if you take cosine A minus B, it's CoCo plus CC. And then when we use these, did we go through any of these in class yesterday? Did you do all of them in class? Did we get to this one? Okay, yeah, so you would take this and you'd put a 0 in for the first one, A, and an A in for the second one we call B, and then it will just turn out to be cosine of A, which is weird, but if you think of A as an arc length going up this way, and then A as an opposite of A going down this way, notice that these x's are the same, aren't they? So the cosine of thetas of minus theta is going to be the same as the cosine of theta. What about the sines? Are the sines going to be the same? Is the sine of theta equal to the sine of minus theta? Now, those are going to be opposites. So this one's going to be the opposite of sine theta. The other one's just going to be equal to cosine theta. This was weird. Cosine of pi over 2 minus a, that just turned out to be the sine of a. And so whenever you see the sine of 30 degrees, or cosine of 30 degrees, the sine of 60 will be the same. Cosine of 10 degrees will be the same as the sine of what? The cosine of 10 degrees will be the same as the sine of 80 degrees. Not too hard. Okay. Did we do this one? Okay. Oh, we did that one too? Oh, wow. Okay. So this one turned out to be cosine A, cosine B, and if this was a plus, this will be a minus sine of A times the sine of B. Okay. So then, what you're going to do with something like this is you're going to put in, for A, you're going to put pi over 2, and for B, you're going to put in A. So let's do that. Cosine of pi over 2 times the cosine of A minus the sine of pi over 2 times the sine of A. Well, on my unit circle, pi over 2 here is 0, 1. And so the cosine is just going to be what? Cosine is the x, 0, and this one's going to be a 1. Yeah. So 0 times cosine is 0. Negative sine of A is going to be your answer for that. How many got negative sine of A for that one? Great. Let's do another one that's probably more important. Would you write cosine of A plus A? And I want to see what you get for that one. So when I do the old CoCo-CC, we'll get the cosine of the first times cosine of the second minus, because if this is a plus, this will be a minus, sine of the first times the sine of the second. And did you get cosine squared minus sine squared? Didn't that bug you a little bit? Don't you wish it was what? What do you wish was in between here? I wish it was a plus, because then it would just be 1, but it's not. This is the cosine of 2a, which is called one of the double angle formulas that you're going to be responsible for. You put a box around that, and then put a star, and then circle the star and put a triangle around it. That's how important that one is. Next, we're going to prove some more. Oh, it doesn't end there. Now what we're going to do is we're going to prove the sine of A minus B. Now to get the sine of A minus B, we saw that sine was the cosine of pi over 2 minus A minus B. Okay? So let's talk that through again. If we have the sine of something, it's pi over the cosine of pi over 2 minus that. We proved that just earlier. Cosine of pi over 2 minus A is just the sine of A. So we just took cosine of pi over 2 minus that to give you the sine of that. I'm going to do a little bit of algebra. Cosine, I'm going to move the parenthesis here so that we get pi over 2 minus a. And this will be minus a negative b, which will be plus b. Are you okay with that? You okay with that? The algebra that I did. So it's the cosine of pi over 2 minus a plus b. So then we're going to CC. Cosine of the first one, pi over 2 minus a, times the cosine of the second one, which is b. Then it's going to be the sine of the first one, pi over 2 minus a, that's the first part, times the sine of b. Now if there's a if this is plus, that means this has to be a minus, from what we proved earlier. So Sandler, what's the cosine of pi over 2 minus a? What is that?
Not sure.
Oh, yes you do. Yes you do. Cosine of pi over 2 minus a. We just did it right here. Cosine of pi over 2 minus a was the same as sine of a. There you go. So this is going to be the sine of a times the cosine of b. We're going to keep this minus sign here. And then, go ahead, Ben, what's sine of pi over 2 minus a? If the cosine of pi over 2 minus a is sine a, what do you think the sine of pi over 2 minus a is? There you got it, cosine a, sine b. And if you're speaking Spanish, this won't be CC this time. It's going to be cosi. So if you have cosine a plus or minus b, it'll be CC. If you have sine a minus or plus b, it'll be cosi. And then, now you can just go ahead and solve all of these. And I'm going to have you do that. This one here, I'm going to remind you that this is the same as the sine of a minus a negative b. And you just go ahead and use this formula that we derived up here. Use this guy and figure out these four. Did anybody get this first one? The sine of 0 times the sine of, or cosine of a, and then it will be minus the cosine of 0 times the sine of a. So the first thing you put in is going to be the 0. Those go here. The second thing you put in is going to be the a. Now the minus is taken care of here in the formula, so don't worry about that. So when I put that a in, now you can see that sine of 0 is 0, and the cosine of 0 is 1. So you're going to get 0 times cosine a minus 1 times sine a. That's just going to be the minus sine of a. That's it. We got that. Minus sine of a. Great. And then hopefully these are going well. Just because of time, I'm going to keep things rolling here. This is going to be the sine of the first times the cosine of the second. This is minus, so we'll keep the minus. Cosine of the first times the sine of the second. Okay. And then on the unit circle, at pi over 2, my coordinate is 0, 1. So the sine of pi over 2 is 1, and the cosine of pi over 2 is 0. So that's going to give me 1 times cosine minus 0. Cosine of a. Did anybody else get cosine of a for that? But doesn't that make sense? The sine of pi over 2 minus a is cosine, and the cosine of pi over 2 minus a is sine. That makes sense. All right. 2 more. So sine of a plus b, sine of a minus a negative b. So this is going to be the sine of the first times the cosine of the second, which I'm going to make minus b, plus is the same as minus minus. So we're using this minus formula as our guide. So we did the sine of the first, cosine of the second, minus the cosine of the first times the sine of the second. Okay. And then I have to remember here that this is cosine B, and this is the opposite of the sine of B, which is going to just make this sine A cosine B minus a minus will be plus cosine A sine B. That's the sine of A plus B. What's irritating is for cosine, the signs are opposite. For sines, the signs are the same. But you're going to use this one to do sine A plus A, and I'm going to have you do that right now. So when I put those in, I just get sine A cosine A plus cosine A sine A. So it looks like, how many sine A cosine A's do I have? How many of those are there? 2 of them. So that is the sine of 2A. This thing used a lot. So put a circle around a star and then another triangle, because we'll use this a lot, especially tomorrow and on the test. Those are the last of the identities that we're going to prove. Now, what in the world are you going to do with this stuff? What are you going to do with all these formulas? Well, we can actually do problems with them, and this is the classic problem. They give you sine of A equals 3/5, cosine of B equals negative 1/2 in quadrant 2, and you're going to find the cosine of A minus B. Now, this looks like it might be really hard, but it's very systematic, and you're going to do great on it. First thing I want you to recognize is how many arc lengths are we talking here? 1 or 2? A and B are different, so they must be different arc lengths. So if you have 2 angles, then you're going to have 2 triangles. And that's important. You can't do this with 1 triangle. So we're going to do, I'm going to draw 2 triangles, 2-unit circles, and for each of these, we're going to be in quadrant 2. So I'm going to go, I like this one here, quadrant 2, here's your A for alpha, your right angle. This says the sine is 3/5. What will this side down here be if this is 5, this is 3? Any guess on what this one is? Good. In quadrant 2, though, it's not 4, it's, there you go, negative 4. Hooray! Okay, so for this one, this is my A circle, A triangle. Now we're going to write, right on the side here, you're going to say the sine of A is 3/5. And the cosine of A, which we just finished here, when we look at this, what will the cosine of A be as a ratio? Not 3/5, but what? Negative 4/5. Very good. Okay, you do the same with the B. Okay, we're going to take this cosine B as negative 1/2. We're in quadrant 2. So we'll make another triangle here. This is B. And you're going to put negative 1/2 in. Well, negative 1/2, here's negative 1, and here's 2. Adjacent over hypotenuse. Any takers on what this height is going to be? Square root of what? There you go, 3. All right, so now next to this, we can write the sine of B is opposite over hypotenuse. The cosine of B is adjacent over hypotenuse. Everybody follow me so far? Hey, this isn't so bad. You've done a bunch of this already. Then you answer the question, cosine A minus B. Everybody's going to have to memorize this one except Abby. No, nobody's going to have to memorize it. Cosine A minus B. You go here and you just write it down. CC. Cosine of A, cosine of B. This is a minus. This, unfortunately, will be a plus. Sine of A, sine of B. And then all you have to do now is just plug in what you found. Be careful, though. Novice, rookies, greenhorns, they're going to make a huge mistake here, and I don't want you to make it on the test. The number one mistake people make is cosine A. What is the cosine of A equal to? It's up there on the board. Can anybody see what it is? Cosine of A. Don't be shy. Negative 4 fifths. Yeah. No, you're right. Negative 4 fifths. Perfect. It's right here. So, do I write negative 4 fifths or cosine of negative 4 fifths? Well, let's look at this again. This is looking for the cosine of A. The cosine of A. Is the cosine of A equal to cosine of negative 4 fifths or just negative 4 fifths? Just negative 4 fifths. The whole thing is negative 4 fifths. Don't be a rookie and make that cosine of negative 4 fifths. I will cry inside if you write cosine of negative 4 fifths because you'll get it wrong, and there's no reason to go through all this work and then get it wrong with a little technicality. What's the cosine of B equal to? Negative 1/2 plus, now we use this one, sine of A is 3 fifths, and the sine of B is square root of 3 over 2. So when you simplify it, it's negative 4 times negative 1 is 4 over 10 plus 3 root of 3 over 10. That's great. You could write it as 4 plus 3 root of 3 all over 10. Both of these are correct. I would love it if they had it either way. And that's what we're going to be doing with these formulas. You're going to start off working with the triangles and the quadrants, and then you're going to answer a question like, what's the cosine of A minus B? And that's what it is. Ta-da! That's it. Go to day 1. Day 1. All right. Just skip number 1 and 2 here. I'd like you to go right to number 22. I have two angles, angle A for alpha and angle B for sine. Two angles, how many triangles am I going to make? 2, yeah. So we're going to draw 2 circles here, and we'll draw those triangles. The first one is going to be in quadrant 4, okay? So that's where A is going to be. And then the second one, between pi over 2 and pi, which quadrant is that? 1, 2, 3, or 4? Pi over 2 and pi. Here's pi over 2. Here's pi. So which quadrant? 2. So this is going to be your beta. Okay? So then you fill out the triangles, and then don't forget to write sine of A, cosine of A. Sine of B, cosine of B. And then you just go ahead and answer their question. What's the cosine of alpha plus beta? Co minus C. Okay, and then this one's going to be the same thing, but there's going to be co plus C, and you're going to plug those values in. So for now, you're going to do 22, 23, 24. Good practice for those three. I like 26 and 32. Those are both great ones. This one, if you have time, do this Challenger if you have time, but I think we're good. I think we're good with that. Okay, so see if you can finish this number 22.